Okay, let's continue with 5.2, perpendicular bisectors. This is part 2 of the lesson. When we look at the word concurrency, you may notice the part that says currents and con. Now, the current comes from the word current, which is, you could think of it as currents in the ocean, flow, and con is together. So con means together, and currency means like the currents, for example, in the ocean, or things that go in the same, lines that go in the same direction. So lines that are concurrent are lines that intersect. For example, here you could have 1, 2, 3 lines. These 3 lines intersect at this point. That means these 3 lines are concurrent lines. In other words, intersecting lines are concurrent lines. Concurrent is a synonym of intersecting. The point of concurrency is the point where all the lines intersect. Recall that 3 perpendicular bisectors of a triangle are concurrent, and the point of concurrency has a special property. Theorem 5.4, concurrency of perpendicular bisectors of a triangle. The perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices of the triangle. Now, what does that mean? If we look at the sides of each side of this triangle, we'll notice that there's a midpoint on each. Side BC has midpoint E. Now, how do I know E is the midpoint? Not because it looks like it's the midpoint. We know that it's the midpoint because in the theorem, they're telling us that segment PE is a perpendicular bisector. And by definition, every single perpendicular bisector must go through the midpoint. That's the definition of perpendicular bisector. It's a segment that bisects another segment, so that means it splits it into 2 congruent parts and forms a 90-degree angle. And it crosses the segment at the midpoint. So because PE is a perpendicular bisector, by definition, E must be the midpoint. Now that means this is 90 degrees. PF is also a perpendicular bisector, so F is the midpoint. And PD is also a perpendicular bisector, so D is the midpoint, and it forms a 90-degree angle. Now, these 3 perpendicular bisectors intersect at point P. That's the point of concurrency. Now, this theorem tells us that the point of concurrency is always equidistant to every vertex on that triangle. So, in other words, because this is the point of concurrency, PB is congruent to PA is congruent to PC. Every single point of concurrency is always equidistant from each vertex of the triangle. Now let's apply that to some practice problems. Here we have a word problem about concurrency of perpendicular lines. It says, 3 snack carts sell frozen yogurt from points A, B, and C outside a city. Each of the 3 carts is the same distance from the frozen yogurt distributor. Find a location for the distributor that is equidistant from the 3 carts. So first of all, we need to connect the points to actually form a triangle. So let's connect A to B, B to C, and A to C. We have our triangle. Now let's draw our perpendicular bisectors. Let's kind of estimate what the middle of AC is right here. So there has to be a perpendicular, not quite through, there has to be a perpendicular bisector right about here. Then there's another, the midpoint looks like it's right around here. And there's another perpendicular bisector right there. And then finally one right here. And it needs to go, it's 90 degrees. So the point of concurrency seems like it's right here where the 3 perpendicular bisectors meet. So notice that we found the point of concurrency by drawing all the perpendicular bisectors and allowing them to intersect. Where they intersect is the point of concurrency. And that point is where they're equidistant. So at this point, that's an equal distance from A equal distance from B, equal distance to C. Great. Now, the point of concurrency has a special name. It's called circumcenter. Circumcenter is the point of concurrency of the three perpendicular bisectors of a triangle. It's called circumcenter of the triangle. The circumcenter P is equidistant from the three vertices. So P is the center of a circle that passes through all three vertices. So here we have an acute triangle, and this triangle is inside of a circle. Notice each vertex of the triangle touches the circle. We draw the perpendicular bisectors. So this is a perpendicular bisector because it forms a 90 degree. This one forms a 90 and a 90. They meet right here. P is inside the triangle. So the circumcenter could be inside the triangle. The circumcenter happens to be the center of the circle. So think of, when you think of the word circum, you could think of circumference. So it tells us that circumcenter is the center of a circle. Circumcenter. Now here we have a right triangle. If we draw perpendicular bisectors, so this is the midpoint. So there's a perpendicular bisector right here. It forms a 90 degree. This from this side, this is the midpoint. So this is the perpendicular bisector, forms 90 degree. And on this side, this is the perpendicular bisector, forms a 90 degree. Notice the three lines intersected right here. It didn't intersect inside the triangle. In this case, the circumcenter is on the hypotenuse of the triangle, or on the side line of the triangle. But it's still an equal distance from each vertex. Equal distance from here, equal distance from here, equal distance to here. The circumcenter in this case is on the triangle. The circumcenter could also be outside of the triangle. So we can draw our perpendicular bisectors. Here's one. Here's another one. And here's another one. In this case, they intersected outside of the triangle in an obtuse. So it seems to be that in an acute triangle, the circumcenter is inside. In a right triangle, it's on the triangle. In an obtuse triangle, the circumcenter is outside of the triangle. So the location of P depends on the type of triangle. The circle with center P is said to be circumscribed about the triangle. So because this circle is outside of the triangle, it's called circumscribed. So what you need to remember is that acute triangles have their circumcenter inside. Right triangles have their circumcenter on the triangle. And obtuse triangles have it outside of the triangle. So here it's inside for an acute, here it's on the triangle for a right, and here it's outside of the triangle for obtuse. Great, and that's it for 5.2, perpendicular bisectors. I'll be posting another video up that has practice problems from 5.2 to help you with the homework. Great, hope you enjoyed that.